Dr. Broman and Professor Guski. We would like to start with Module 1, Life Quality. Mr. Schreckenberg has prepared himself already to start. Dirk Schreckenberg is the study manager of the Center of Applied Psychology, Environment and Social Studies in Hagen. And he deals with environmental and traffic psychology research on the effect of noise. Thank you very much. Good morning, ladies and gentlemen. Take your cups of coffee inside and enjoy, hopefully, my presentation. Although today there might be some terrifying figures with respect to the effect of noise. But let's wait and see. All right. This morning we deal with the study on life quality. In this partial study, different organizations participated, led by Müller and Partner, that was acoustics, sound plan and ABIA consult. Then the interviews that were carried out, telephone interviews, they were carried out by the Social Scientific Survey Center Duisburg and the Ruhr University, together with our office, ZEUS GmbH, dealt with concepts and evaluation. In addition to the highly constructive and supportive scientific support and quality assurance, we also carried out some internal quality assurance. Professor Schick and Professor Schümer, the two are psychologists, and they made sure that quality was the right one. They looked into the effects and gave advice, and Dr. Vogelsang, who was mentioned several times yesterday, also took care of the correlation between acoustics and effect. And he made some valuable suggestions. So I would like to thank everyone involved at that point. Today, after I've described the tasks and how we carried out the study, I would like to share with you the results of the study. And there are 4 areas that we looked at. That is the time comparison that we studied at Frankfurt Airport, then comparison of sites, that is Frankfurt Airport compared in terms of effects with other airports, and then we compared sources, that is air traffic noise, road traffic noise and railway traffic noise, looked at the different effects here, and we looked into other effects that I'm also going to talk about. You will see some abbreviations. IATA, that's the code for the airports BER, Berlin-Brandenburg, CGN, Cologne-Bonn, FRA, Frankfurt, and STR, Stuttgart. So if you see these abbreviations, I mean these airports. Now, let's take a look at the WHO report 2011 and the annoyance-free years that are lost every year. Then you can see that many of the calculated years are due to sleeping disorders, and also mainly are due to noise annoyance. Not that noise annoyance is so bad. We all agree that cardiovascular diseases, cardiac infarctions, etc., are more severe diseases or health damages, but annoyance has many people affected, people who live close to airports, railway links and roads. And it's interesting for us, and we share that the WHO regarded annoyance as a health-relevant factor, and this is also due to the definition of health that WHO has determined years ago, and that is well-being, social, psychological, physical well-being, and not only the absence of disease, of pathological factors, and therefore it's a health-related value for us. And it is part of our partial study here. I mentioned before we had a time comparison at the Frankfurt Airport that we looked into. That is the impairment situation 2011 before the Northwest runway was opened, and we had a panel study that we developed, and we then asked the same people in 2012 and 2013. So in the first year after the opening of the runway. In Frankfurt we studied it, but also the 3 other airports were looked at, Berlin-Brandenburg, and that's logical, you all know. That was before the opening of the airport. You know, we wanted to do a follow-up study, but we all know that this has not been possible because the airport has not been completed. Cologne and Stuttgart was also looked at as so-called existing airports where no changes and modifications will be made, and Cologne-Bonn with a very marked share of night flights. 30%, as it were, and Stuttgart, an airport that has night flight restrictions, and between 2200 hours to 6 o'clock, we have 7% night flights. We also looked into the sources, compared them with road and railway traffic noise, and we also looked at the combination, that is air noise combined with road and rail noise. Here you can see a very complex model with a lot of boxes and lines. This is the concept that we used at the beginning of the NORAH study. It was, so to speak, the framework for all partial modules. And everywhere where you can see the figure of 1, that's the part that we dealt with. And here it's central that we dealt with the boxes in the middle. That is the psychological effects triggered by noise, and this is the disruptions, the perception of annoyance, coping efforts to come to terms with noise, and depending on how well you can cope, annoyance develops as a result. And we have another big block on the right-hand side of accompanying factors, factors of influence, that is the situation, insulation, window positions, and also factors that are mainly due to the person, the individual, that is susceptibility, sensitivity to noise, then also confidence in those who are responsible for noise abatement, and also the attitude towards the source of noise as such, whether you regard the one or other source of transportation more damaging to the environment or not. All this has an influence on the way how people can cope with noise and how they come to terms with it. And these factors, these annoyance factors, that results from that, and that was the hypothesis derived from the stress model, will have further impact on health and life quality related to health for the long run. Here we have the 4 study regions. On the left-hand side, Frankfurt, on the right-hand side, Berlin, left down there, Cologne, and on the other side, Stuttgart. And you might see with the different maps that you have black lines and contours that surround the regions, and the dots inside are the addresses of participants, of test persons, and the black lines delimitates the study regions. It's the contour that is developed if you consider 40 dB continuous level during the day and during the night. Put them together, and then you call it the surrounding contour. That's how the acoustic experts call it. Normally it's the continued 40 dB noise level during the day that is taken, but there are some regions, in Frankfurt for example, Neu-Isenburg, it might happen here that the night noise level is higher, and we included the addresses that would fall under that definition as well, the 40 dB. Altogether, we had a lot of respondents that had less than 40 dB impact, and just as in the case control study, we calculated down to 35 dB, and it also happened we had some participants with even lower noise levels. Then we marked that as less than 35, but then we didn't continue the calculation whether it was 28 or 17, you know. At some stage, acoustics experts would say it doesn't make sense any longer. All right. You can see the participants, 9,247 persons in the panel. In Frankfurt, another 9,513 participants that responded more in direction to road and railway noise and combination noise. And then in Berlin-Brandenburg, we had 5,500, in Cologne-Bonn 2,900, and in Stuttgart 1,980. The surveys were done in such a way that we got the information of the registration offices of the municipalities, and then we stratified random checks. That is, we stratified according to noise level classes, and per noise level class we made random selections, because we wanted to avoid the situation that you only have few number of participants in the upper noise levels. We wanted to have just as many participants in the different noise level classes, that is lower ones. And for the exposure response curve, it's really important, because then you can say that the different dots on the curve are having more or less the same way. So stratified coincidental selection, and as it was a telephone interview, we allocated telephone numbers to the addresses and informed the respondents by writing them a letter asking them to participate in the survey. Then we carried out the questionnaire with them, and then we had more address-related noise levels that we determined and that we allocated to the respondents together with their addresses. In Frankfurt, due to the fact that we, in relatively short period of time between the earmarking of funds for the study and the building of the new runway, was summer vacation time, and then hardly anyone was around. So that was a challenge for us. So within a very short period of time, we had to ask quite a number of people for the panel study, so we did it the other way around. That is, first of all, we informed people in our letters, and then with the number of letters, we selected the telephone numbers. So it was the reverse direction, so to speak. I point that out here because this has an impact on the response, but I will show you later. This process, in terms of the concept, was harmonized with the data commissioners of the different authorities, and we were authorized to carry it out that way, and that it was in order with our data protection law. Now you can see the participation, and for some people it might be terrifying. Also for me, you know, these are values that are definitely not satisfying, and we are not happy with them. And on an annoyance scale of 1 to 5, the situation of 5, you know, that means strong annoyance, very strong annoyance. You know, between 7% and 31%. There were response rates, and 31% nowadays for telephone interviews. Unfortunately, that's normal. Like from the Robert Koch Institute, we have health service interviews on a regular basis. On the rate of 2014 was 22%, on 2012, 28%. So we are more or less in the region what we we expect nowadays. In Frankfurt, it's lower for the reasons mentioned before, 7%. You know, those we informed by letters. That's the number that we use, and 17% was added here. This refers to the number of telephone numbers that were available to us, and this is easier to compare with the other sites where we had telephone numbers as well, and we drew the lots. And, 7, respectively 17%, that's very low, and we intensively dealt with the question what it means for the results, because the response rate is so important to find, do we have a problem, do we have a distortion? And the next question that comes up is, what does that mean for the results? Can I just take them? Are they robust? Are they higher or lower? What do I have to do here? And we did a lot of modelings. I can't mention everything here. Professor Vogt will talk about it in further detail, and we came to the conclusion, yes, we cannot rule out a distortion, but no, it has hardly no effect on the exposure response curve, and we regard the results as robust. Okay, that is meant to show you that this partial study is already relatively complex. We made some random samples, we determined a panel, we compared with other random samples of other airports. We have random samples that rather refer to road traffic, others to railway traffic, and combined noise. And we have many partial steps and individual surveys that we carried out. Now, the results. Time comparison, first of all. That's the situation at Frankfurt Airport. Here you can see, first of all, the change in the panel study with respect to exposure 2012. That was after the opening of the northwest runway compared to the situation before. That's the 24-hour continuous sound noise level on the x-axis, and on the y-axis you have the differences, 2012 compared to 2011. We have increase and decrease. We have many regions where it was plus minus 2 dB, and it remained more or less constant. The most marked changes, increase or decrease, go up to 14 decibel, but mostly would be in the range of 4 to 6 dB of change up or down. And this is the night noise level shown here. We know that in the second year of the survey we had already the core rest period night ban of 2300 hours to 5 o'clock. And in the noise levels, they change in the sense of a reduction of noise level is shown here. But 2012, we also have some increases. And the reason here is that the night noise level is higher 1 hour before and 1 hour after the core rest period, and then the traffic situation has not changed. And in cases where we have an increase of night noise level, then it has increased in these marginal hours, that is shortly before or after the core rest period. In the model that we calculated, apart from the noise level, the continuous air noise, and for railway and road traffic noise, it's other noise levels that we added here. But to control all models, we also looked at the competing, so to speak, continuous noise levels of the other sources of transport. And we also had some methodological adjustment, like questioning mode. We also made the offer. It was mainly telephone interviews that we carried out, but those who wanted to have another form of interview, we also offered the online version. And there might be differences, and this also happens, and they have been modeled and considered. We also have some demographical variables, attitude-related values were added. All this was incorporated. pre-analysis were carried out as well. As we had longitudinal data, we could do that, and we could see what most probably is rather the cause or the result. The annoyance might lead to the situation that I change my attitude towards air traffic or other transportation sources, and then my sensitivity changes. And if I take a longitudinal approach, then we found both. That is, the air traffic evaluations, and the same is also true for road and railway traffic. Well, the evaluations was rather a moderating value, whilst the expectations and the coping capacity is a secondary reaction. And that means that in the consideration, we could not use it every year as factor of influence, but in the longitudinal approach, we did so, as the expectations that built up in 2011 definitely had an impact on the annoyance perception in 2012 and 2013, and that actually happened. We assumed that if there is a change, and that was the assumption on our side, the opening of the new runway, that then the annoyance level would go up, and sometime later, in our case, 2013, probably it would go down a bit, but not back to the original level. And it's known from literature, the authors that first of all showed that graph from 1997. You know this change effect, and it's important. If in politics we use the exposure response curves, and in Europe we have the EU or MEDIMA curves, and it's important to ask also, are they valid? Are they applicable for the region for which I plotted the curve? And our assumption was that this is not the case. Now, if you take a closer look at that, you have to distinguish whether it's residential areas where there was an increase or a decrease or a stable situation. And in the case of a decrease, we can see that basically, if the annoyance was only due to acoustics, there should only be one line. On the x-axis, you have the continuous noise level, and the y-axis, you have the level of annoyance of 1 to 5. And as we had different lines here, you can recognize already that you have a stronger effect than only acoustics. In the case of reduction, we have a stronger decline in annoyance in 2012 and 2013 than based on the 2011 modeling assumptions. In the air noise stability group, that's how I want to put it, it remained more or less the same. There are some overlappings, and it's interesting to look at the last group that had an increase. And we see that in 2012 and 2013, the annoyance is clearly higher, especially in the lower noise levels, that is 55 to 60 decibel. Here, the situation is that the annoyance is much more characterized, much more marked than we would have been able to forecast in 2011. And that's what we call the change effect. And you can quantify it and say that in the increase group, this effect led to an additional increase of 2 to 6.5 dB. And that's a clear effect. And in order to determine this curves, we did the growth models, the statistical growth models, and they do two things. First, they measure what factors of influence have an influence on the starting situation in 2011 and what factors of influence have an impact on the change. And as a matter of fact, the continuous noise level definitely is an important and central figure, and it has influence on annoyance. Other factors like coping capacity, attitudes, home ownership, also to a certain extent home ownership. Homeowners are more annoyed than those that don't own the house they live in. And in the changes that occurred 2012 and 2013, it's not the case that the additional noise level led to this additional shift. It cannot explain that way. It's the other factors, rather. That is, first of all, the noise coping capacity. People have found, right, something has changed here. And with my ordinary strategies, with which I tried so far to cope with the situation, you know, if a plane flies over my house, that then I close the window or whatever, this coping didn't work any longer, and they had to change their behavior at the time when the noise situation, the noise event happened, and the stress that I have needs to be dealt with in a different way. So this is the coping capacity and also the expectations that had an impact. They were decisive for this additional change effect when it comes to annoyance. And we had a similar observation for the other groups, but with the air traffic noise annoyance, it's most marked. With sleeping disorders, probably the core rest period and its introduction led to the situation that in 2012 and 2013 the reported sleeping disorders for sleeping throughout the night went down, whilst disruptions in the morning increased a bit, which is logical because as of 5 o'clock the core rest period is over, and then planes fly already. And this is shown quite nicely in the graphics. With respect to life quality, here we also showed on the x-axis what different noise level classes we have, and on the y-axis we have the questionnaires about the grade of psychological life quality. And the red straight line, horizontal line, that's the national average, and this is more or less the same that we report here in terms of life quality. There is a slight decline, however, in the higher noise level classes, but that's a group of those that reported a decrease of noise level due to air traffic. And also in the stable class we have little change as a function of the noise level, but we have a bigger change of life quality, psychological life quality, in the group of increased air traffic noise. With an increase of air traffic noise, those that in 2012 had this increase and that were more exposed showed a lower psychological life quality. And then we also found that this is somehow imparted by noise annoyance. The models that we calculated, and if we included noise annoyance, then the noise level effect disappears, but the annoyance factor stays as an important factor. That doesn't say that noise doesn't produce this effect, but it tells us in what way life quality is influenced, and that is rather annoyance. And this is true for all airports. This is true for all sources of noise, that is road traffic, railway traffic noise, etc. So that's always what we find. And this is also true for physical life quality. Here you have the same presentation of the recorded physical life quality. Here the effects are not as strong, but they go in the same direction. Now, if we take a look at the curve of air traffic noise annoyance of NORAH, and if we compare it with the RDF study of 25 that was also carried out in this region, the green curve, you know, that's the exposure response curve of the RDF study 2005, and here you can see the highly annoyed persons as a function of the continuous noise level, and you can see that in 2011 to 13 the noise annoyance has increased substantially. It's not so much the difference between 2011 and 13 that is relevant, but rather the difference between 2005 and the three curves that we plotted in the NORAH study. If we add the other airports, then we see that they are in between the two Frankfurt curves of 2005 and the NORAH curves. So also at the other airports, the share of air traffic noise annoyance was higher than the RDF study showed in 2005. And already at that time it was the case that this green RDF curve was higher than the EU curve that we have. We did not dare to show the EU curve. It's somewhere here, down there. And the RDF curve was increased already at that time, and the NORAH study shows that the curves are even higher at all airports. This is an effect that we also observe elsewhere. That is, in the course of decades, we should say, the number of people annoyed by air traffic noise has increased tremendously. These sleeping disruptions and disorders, these are the reported ones, not the ones that were measured, that we talked about yesterday. In 2011, in Frankfurt, we had the highest share, and it goes down in 2012 and 2013, probably due to the introduction of the core rest period and the ban of night flights. And it follows the logic of the other curves. Now, comparison of sources. A dramatic difference between highly annoyed people by air traffic noise compared to road and railway traffic noise. With the same continuous noise level, which you see on the x-axis, we have a marked higher share of air traffic noise annoyed people in our region. In terms of the grading, we expected that. That's a result that we have known for many, many years, that air traffic noise is more annoying at the same noise level, although the difference is much clearer here. And what we also found was that in earlier studies, the difference that was found between road and railway traffic noise was, in the way that they said railway noise is less annoying than road traffic noise, and that led to a bonus, so to speak, for railways. But it has been abolished now in Germany, and this so-called bonus or annoyance difference is no longer seen now between road and railway traffic noise. And in later studies, like the one of colleague Löscher, from the Alpine Valley and the Rhine Valley as well, there we have a similar effect, that the bonus for railway noise is no longer given. Now let's have a look at the combined sources of noise. Probably I should explain here. On the x-axis we have the continuous noise levels, and on the y-axis we have the grade of annoyance. That is the one that is total annoyance. We asked how much people feel annoyed by the different sources of noise, and the black curve with the black dots, here, noise annoyance is related to the total noise level of the different sources here. We just add it up. And the red curve, here the total noise level annoyance was extrapolated to the air traffic noise, and the green curve is related to road traffic noise. And these curves shall illustrate that the total noise annoyance follows the air traffic noise level and the combined noise level, but not the road noise level. So this is a total noise level oriented towards road and air traffic noise, but it rather concentrates on the air traffic noise. And if you take a look at a different plotting or presentation, here you can see in the combined noise level, continuous noise level, is there a predominating factor by air traffic noise or road traffic noise? If air traffic noise is predominating in the total, in the combined noise level, then we have an explanation. And if road noise level is predominating, then the noise annoyance is not that marked, not that high. So we can conclude that the air traffic noise annoyance in all noise level classes really determines the total perception of annoyance. And the same is also true for railway traffic. So it's always predominating here the air traffic noise. Then we have communication disorders that we looked into, disorders of other sources, then dissatisfaction, satisfaction with residential conditions, general sleep quality and expectations to the air operation, and the expected or experienced fairness when it comes to planning. We asked that question about air traffic in Frankfurt, and there's also some correlation to the noise level, also when it comes to confidence in people responsible for noise abatement. Conclusion. My colleagues and I agreed that the evaluation shall be done by Mr. Vogt, and well, I would like to thank you very much.
Dankeschön, Herr Schreckenberg. Nehmen Sie Platz gerne auf dem zweiten.
Thank you very much. Mr. Schreckenberg, please take a seat and let us continue with Mr. Vogt. But before we come to that, let us congratulate Mr. Brink. It's his birthday today.
Wir machen weiter mit Herrn Vogt, der gerade hochkommt. Professor Joachim Vogt.
Professor Dr. Joachim Vogt. He is heading the Technical University Darmstadt, and he is doing research on technical analysis. Good morning, ladies and gentlemen. In the WBQ, we wanted to make sure that all members are reading all NORAH documents, and it is always two of us who were responsible for one study. And Mark Brink and me were responsible for the life quality study. Let me talk about the most important aspects of that study. I would like to talk about the news, about the sensitivity analysis and the limits, and what we did in order to cope with the limits. And then finally, I would like to draw a conclusion on behalf of the WBQ. The report contains 629 pages, and 209 pages can be found in the annex. So we're talking about a huge document. There are some benefits. We have, for example, the cross-section comparison for the Rhine-Main region for the years 2011 to 2013, which gives us a detailed insight into the noise development after the introduction of the core rest area in Frankfurt and after the opening of the northwest runway. We could see that there is a change effect, and in Mr. Schreckenberg's presentations we have learned that there is a change effect after the northwest runway started the operation. We could see that noise went up. We could see that the exposure is the same, that there is a little bit of annoyance, but this annoyance is only amounting to 2 decibel. Yesterday, in the acoustic session, we learned that we have an address-related exposure map, and this was not a standard before in the noise research. The change effects were small. This is what Mr. Schreckenberg already explained. Small compared to the year 2005, which means that all the changes which occurred in the year 2011 to 2013 are minimal if you compare them to the years 2005 and 6. If you have an LEQ of 50 dBA, we're talking about 30%, and in the years 2011 to 13, it was rather 50%. We do not know why we have this kind of increase, even if we have the same sound levels. People feel more annoyed, and I think we have to do much more research to understand why the people feel this kind of annoyance. The multicentric approach of that study compares Frankfurt, Cologne, and Berlin, and we have precise noise curves of these airports. We can see that we have differences with regard to the aviation events of the time regime, and in Frankfurt we can see many changes. Cologne, Bonn and Berlin, however, are quite stable. The exposure response curves differ widely in these locations. They cannot be compared that easily. Then we also made a comparison of the aviation noise with railway and road noise. We focused on a statistic control of confounding. This is what Mr. Schreckenberg and his team did, which means we gathered information about all kinds of noise sources. And we started comparing the exposure response curves for the different noise sources. We can see that the people felt much more annoyed by aviation noise than by other noise sources. And we also gathered more information about the combination of different noise sources. The bandwidth of individual questions, which were in the range of Module 1's research, was really very wide. We focused on different acoustic key indicators or parameters, and the continuous sound level is explaining a lot of annoyance, but we also know that the peak levels and the numbers above threshold 55, which means the 5 movements with an individual sound level of 55 decibel or even more, that these kind of values are not going down, and therefore we have to think how to use these kind of metrics better in the future. Then we have annoyance in different time slots, different time slices. We know that in the evening and early in the morning, the people are very sensitive with regard to noise. We did not take any acoustic context factors into account. The personal factors which influence the noise perception, personal perception and the assessment of noise protection measures, these kind of things were also taken into account, and we have learned that the two latter elements have a major impact on the perception. And of course, it is also important to have information about the social factors, that people trust in the people in charge, that they feel treated well, that there is something like fairness, and this was in the COSMA study one important element. These kind of social elements were also analyzed. These kind of question and answer formats were standardized. We used international questionnaires, and we also tested them in the psychometrical point of view. And this has not been a standard in the acoustic research as well. We did these psychometrical tests, and we wanted to make sure that the answers refer to a certain quality. Module 1 tried to focus on the method of ordinary least square, OLS, regressions. We know much better than before how the different elements influence the personal perception of an affected person. If somebody is not happy with his or her residential area, then that person will be stronger affected by noise and by annoyance. And also the standard of living is a factor which needs to be taken into account. And we have learned that communication is also of utmost importance. We need to create something like a trustful basis for discussing annoyance with the affected persons. And then we could see that there are also secondary reactions, that the people who feel annoyed by noise also suffer from other problems. Apart from the ordinary least square regressions, also other methods were used, the latent growth curve models, for example, which means we were able to describe in a statistical manner the annoyance of persons who suffered from noise within the past 3 years. We described different dependencies. And we also used the generalized linear models for the cross-section comparison. We developed, for example, a basic model for adjusting the questions here and there. It makes a difference whether you ask the people with an online questionnaire or whether you pick up the phone and talk to them directly. And we saw that there is also a difference. Bootstrapping is a method which is being used to check whether central exposure response models are changing. If you take the existing data set with 5,000 information and take some random samples, and then you will get information whether these random samples might have an impact, negative or positive, on the exposure response model. These sensitive analysis, sensitivity analysis, like the bootstrapping, for example, were analyzed together with a consortium, and you can see a whole list of sensitivity analysis which were focusing on personal characteristics. We analyzed what kind of personal characteristics can be found in the different sound level categories. Then panel random samples were compared to specific socio-demographic population characteristics. If we see that, for example, an age group was not represented well, or a social group was not represented well, then these random samples were controlled. Then a non-responder analysis was carried out if people were selected at random basis to participate in the study, and if these people did not want to participate in that study, we asked them, why don't you want to participate in that study? And we could see that a whole lot of people simply did not have time to take part in the study. And two other groups which are quite interesting are the groups who have lost their hope that something will change. They said, the study will not solve my problem, and this is why we're not taking part. And another group said, we're not affected by aviation noise, and this is why we're not interested in taking part. So if somebody refuses to take part in a study, then it is not a general refusal, it is simply based on different reasons. The 3,508 test persons which took part in the studies in the third years have another exposure response impact than the 9,150 persons who started at the beginning in year number 1. And in 2013, a new group of probants was recruited showing the same exposure response effect or impact like the persons who started participating in the study 3 years ago. We could not see many differences in the exposure response rates, the effects with regard to different continuous sound levels, the LEQ, for example. This is what I already addressed. The LEQ is a good explanation for an annoyance, and of course the questionnaires are very important, and they have been adjusted here and there. And this is what we did in the basis models already. All in all, we have to say that the results of the study are very robust. The exposure response curve for 1 year, for one source, for one location will not change that much. And the parameters which were presented by Mr. Schreckenberg for the years 2011 to 2013 are, as far as the sources are concerned, the aircraft, noise and the railway and road noise different from location to location. But within the data set, the exposure response rate won't change if you carry out all these sensitivity tests. But still, there are some limits due to the fact that persons having no registered telephone or persons who do not react on your letter participate in that study. This is why we had a quite low group, a little group of probants. We had to close some gaps here and there. But in the module, it became visible that the possible distortions in the sensitivity analysis were not existent. We did so many sensitivity analysis, and therefore a distortion, and this is what Mr. Schreckenberg said, cannot be excluded to 100%, but it's quite improbable. The limitations were presented in a very transparent manner, were discussed thoroughly, and this brings me to the last bullet point of that slide here. The random samples were big enough to detect the smallest effect on the basis of a power analysis, and with the RDF data we could learn that the direct impact of noise on life quality is the smallest one, because as far as life quality is concerned, there are so many other effects which have to be taken into account, and these effects could be analyzed with 2,500 test persons, and we had 3,500 test persons, and therefore the group was big enough to analyze the smallest effects. And this brings me to the conclusion. The Module 1 test has met all the requirements, all the prerequisites which were described at the beginning of the study. We could see the causal relation between the exposure-response relationship with regard to time, location, and sources, and the comparison. We can see that there are national and international correlations. We can see that it is a comprehensive study which is gathering a large amount of random samples. We do not know that there is any other study which is so comprehensive like this one. We had a problem with a low response, but we have dealt with that problem successfully. Everything was done, also post hoc, to make sure that there are no distortions in the random samples which were taken. So we should congratulate the team on that excellent study. It is certified by the WBQ, and this brings me to the end of my presentation. Thanks very much for listening.
Der nächste Vortrag dieses Morgens wird auf
The
Englisch
next presentation will be in English, and I would like to refer you to the simultaneous interpretation. In the silver box you find headsets, and channel 1 will be the German
The external
interpretation.
review of the life quality study comes from Dr. Ian Flindell. He's an independent consultant and researcher, visiting researcher at the Institute for Sound and Vibration at the University of Southampton, and has been involved in many, many airport noise research projects. Dr. Flindell.
Thank you. There is my picture. So I apologise for speaking in English, but many of you seem to know that anyway. I'm talking about Belästigung and Lebensqualität. Did I get that right? I'll also try Fluglarmbelästigung. Okay. Next slide. I just want to go through a couple of sort of basic theoretical questions first of all. So we're talking about exposure-response relationships at the top of the slide here, and the purpose of any of these studies is basically to establish or to update exposure-response curves between reported aircraft annoyance. Now, I mean, I don't know whether it's actual annoyance, it's reported aircraft annoyance, which is what people say when you ask them a question about it. It's not necessarily the same thing as what they really feel, and also reported quality of life, and standard acoustic parameters such as LEQ, LDN, LMAX. Now, there's some German words for those, but I'm not sure what they are. And why do this when a considerable amount of similar research has been carried out already? That's true. But in my opinion, the reason for carrying out more research is because the situation at every airport is different, and we know that exposure response curves vary considerably between different airports and in different situations. We already know this, so we want to see what's happened at Frankfurt. Now, exposure response curves vary when you use different metrics, and I want to illustrate that with some theoretical, this is a hypothetical random example. This is what we're talking about for the non-experts. So along the horizontal x-axis, we have exposure to aircraft noise, Flugalarm, and that's measured using a standard acoustic scale. There are different ways of measuring aircraft noise exposure. There's been lots of different methods explored in the past. In the EU, we tend to standardise on the equivalent continuous sound level, LEQ-based measures, also sometimes on maximum sound levels, but that's more problematical because you don't know, but this was referred to yesterday in the acoustics discussion, we don't know whether the maximum refers to the noisiest aircraft event once per week, once per month, once per day, or whether it's the average maximum or whatever. Whereas the LEQ, the continuous exposure level, is a standardized average, but it doesn't necessarily relate particularly well to the response measure on the vertical axis, on the y-axis. Now what I've plotted out here is just two hypothetical studies generated with randomly generated data, the blue dots and the red dots, and we show different linear regression lines between the two, and a hypothetical example, which if you can remember what the chart showed, a general trend for higher response. The response increases as the sound level increases. A considerable amount of scatter, variance. There's always scatter of the individual data points, and it's a question of how wide that scatter is determines how representative the regression line is of the data. And there were also significant differences between the blue dots and the red dots in my hypothetical example. Now, a key question for policy interpretation, what do you do about this, is can the observed relationships be used to predict changes in response when you change the exposure? That's what regulators and the public would like to know. And in any real comparison, which is what we have here in the longitudinal comparisons at Frankfurt, what particular changes actually caused the observed differences in response or the output? So was it the introduction of the new runway? Was it a general change in people's sensitivity? Was it the nighttime ban? How important were all these changes which took place? So the methodological questions we have is, does the exposure metric, as used on my chart or in all the other charts, does that represent the most relevant features of the actual exposure to explain the variation in the average exposure-response relationship? Because if it does, then you can use it for predictive purposes. Now, there is increasing evidence, I have to say this because it's true, that LEQ-type metrics do not fully represent the effect of changes in the number variable. This is very significant. And so, does the response metric actually represent the most relevant features of the actual response? The LEQ does not measure annoyance, it just measures sound. And that's the difference between sound and noise, or skol or larm, I think. Is that right? Yeah. The skol is what you measure with an instrument, and the larm is what a person can tell you about. Okay. So what does this word, Fluglarmbelastung, or aircraft noise annoyance in English, what does that really mean? Everybody has a different opinion about that. We ask people, we have ISO standard methods and questionnaires to ask people that, but we're not sure what it really means for different individuals. And also, do respondents always understand the response scales in the same way? This is probably where the non-acoustic factors, which my colleague Dr. Schreckenberg has been talking about, that's probably where they're really important. So let's have a look at the specific aims of the NORAH quality of life study. We have a longitudinal comparison over time, 2011, 2012 and 2013 at Frankfurt before and after the new northwest runway opened. Now, longitudinal comparisons, that's a longitudinal comparison, they actually help us to understand cause and effect. Gives us the possibility to be more confident about predictions made on the basis of the exposure-response relationships. But only if there happen to be, in the field experiment, if there are significant changes actually happen in a small number of variables. If you have too many variables change, then you don't know which ones were responsible for the change in response. And it's necessary to measure all of those different variables in order to identify which might have changed. And we often have a problem with covariance, which is a statistical problem, which I'm sure Professor Vogt can talk about if there's any concern about that. So unfortunately, the design of field studies, and this one is no different, it's always a conflict or a compromise between conflicting priorities. Now, I'm very confident that the research team here have done their best to learn from previous research. So I don't know that I would necessarily have designed the study any differently at the start, but there are additional things you can learn after the study that if you go on to another study, you might do differently. Okay? So another specific aim of the study is to, number 2, is to compare responses between different airports. So we're looking at Frankfurt, Berlin, Schornefield, or is it Brandenburg? That's not yet open, I'm not quite sure about that. Cologne, Bonn, and Stuttgart. And these other 3 airports have different characteristics from Frankfurt, so you might expect differences in the pattern of response. Cross-sectional comparisons are interesting because they might not actually increase understanding of cause and effect because there are too many differences between the situations at the different airports. So we know that the responses are different, we know that the patterns of exposure are different, but we're not necessarily able to determine which of those differences are responsible for the differences in response because there's too many of them. But it's nevertheless interesting to see if they vary, and you don't know until you carry out the study what's going to emerge from it. Specific aim number 3. Okay, so they've looked at aircraft noise, railway noise, and road traffic noise. I'm not going to try and pronounce Schienenverkehrslärm or Straßenverkehrslärm. But I would like to say that when I was trying to read the summary reports, I found Google Translate very helpful. Okay. Now, as both of my previous speakers have explained, previous comparisons between different sources have consistently shown aircraft noise to be more annoying than road traffic and railway noise at the same LEQ level. They've also shown road traffic noise to be more annoying than railway noise, so we have this railway noise bonus, but that appears to have disappeared. But I'm more concerned about those differences are also dependent on the type of acoustic metric and method of analysis used. That's the first thing. And secondly, I'm not sure what you do about them. And I think that's important for regulatory purposes. Just because people say they're more annoyed by aircraft noise at the same LEQ as road traffic noise, well, what do you do about that? What does it matter? Okay. Other variables. This is actually also a very important part. Increasingly, people are becoming interested in what I call non-acoustic variables. not only we're looking at different response variables such as speech interference and reported sleep disturbance, also looking at noise coping capacity, procedural fairness, trust in the authorities, and these are always very interesting variables, and as we've already heard, they have a considerable explanatory power in terms of the statistical analysis. And if you can't change the sound level, for example, in terms of mitigation, you might be able to change the public's perception of the fairness and reasonableness of the way they've been treated. Or one of the things that one of the important issues that I'm always going on about is the question of balance between the social and economic benefits of the airport compared against the environmental costs. And I think that in my experience in the UK, when we try to explain the whole issue to the public, many of the public are very reasonable and they understand and they appreciate the decisions that are being made. They don't necessarily reduce their annoyance, but it may mean that it might change their degree of acceptance of the situation. So this is interesting because I think the ultimate purpose of there's two purposes of these research. One is to fundamentally increase our understanding of human behaviour and the human condition, but secondly, we're really important to inform what is the best mitigation policy, what's going to be the most effective. So let's have a look at the methods. The study areas were defined very comprehensively, very professionally, by means of day and night LEQ aircraft noise going right out a considerable distance out from the airport. That's kind of an innovation because many previous studies have not gone so far out from the airport as this study. So that's good. But we know that there are complaints about aircraft noise from considerable distance out from the airport, and it's important to study those people, and it also increases the number of people that are actually included in the overall target area. And then these areas were divided into, if you like, concentric bands of increasing noise exposure in 2.5 decibel steps. And that's a difficult and comprehensive and expensive operation. I believe that was done very, very professionally. All those residential addresses within those areas were identified, and then random samples were selected. That's all standard procedures, and it follows industry best practice. But the definition of study areas in these 2.5 decibel LEQ bands does impose some limitations on the types of analyses which could be carried out, and I'll come back to that in about 4 minutes' time, I hope. I still have about until 20 past, I hope.
Let's say 15 past. 15,
well, I've got, okay. It does impose some limitations. So, doesn't always work, this, come on. Okay, no. What's happened here? Right. Response rates. Okay. No, that's that one. Sorry. Okay. Quantitative survey of the residents' attitudes and opinions by telephone interview. Again, with the online questionnaire as an option, with postal invitations to participate. These are all standard procedures and they follow industry best practice. Telephone interviews are a good compromise solution to obtain where you want to achieve large sample sizes, because you can interview a lot of people rather than actually speaking to people individually, which is much more expensive. So for the same money, you can't talk to as many people. And it was important, I understand, in this case, to achieve a large sample size. Now, the question arises as regards response rates. Okay, and that, I understand that's been a concern. And certainly out of the large, 1 or 2 million people in the Rhine-Main area, we have the actual respondents are only a fraction, even though they're in thousands, and the statistical analysis has been very robust of that. We still and statistical checks which have already been discussed at the bottom, nevertheless, there is a possibility, an unknown possibility, that non-participants may have refused because they were less interested in the survey. Only some of those non-participants actually explained their reasons. Some people just didn't answer the telephones. You don't know what they thought. It's a reasonable hypothesis that many of those people just couldn't be bothered to answer. They couldn't be bothered to give up the time to answer the questionnaire, and therefore we might assume they were not as affected as participants. But we also have the possibility of the other way round. So I think that the study group have done the best they can within the limitations of the telephone interview survey, which is, the survey is robust. The results are robust in terms of what they did, but there is still a question mark about non-participants. What were their opinions? We never know that because we didn't ask them. Okay? The standard of acoustic metrics for each individual participant address. Now, this is much greater precision than the industry standard method, which only calculates standard acoustic metrics for the centre of each centroid of each small sampling area. So one acoustic measurement represents perhaps 50 or 100 addresses. My comments on that is that the calculation uncertainties can exceed the differences between the individual addresses anyway. Sound levels do vary in different locations around each house, particularly when we have this discussion about indoor and outdoor sound levels, because we don't necessarily know how much time each proband spent. Proband is a German word. Thank you. We call them respondents or participants in English. We don't necessarily know how much time each person spends in each position around their house. Many respondents or probands are actually out of the house all day anyway. They're somewhere else. So how much does their opinion about daytime noise where they live matter when they're not even there? Okay. So this is a good thing to do these measurements, but I think we need to know more about where the people were at the time to fully exploit that additional precision. Okay. Findings. We've already seen these charts that show that aircraft noise has changed a bit. It's gone down in many areas, but I would say that these charts do conceal to some extent a complex pattern of increases and decreases in different areas around the airport. And so actually there is scope for more detailed analysis, which I think they've done to some extent. Findings. So changes in annoyance. These are Herr Schreckenberg's charts. Under reduced aircraft noise conditions, stable aircraft noise and increased aircraft noise, we see these differences. Small reductions when reported annoyance when the aircraft noise is reduced. There's really no change in reported noise annoyance when aircraft noise is stable, but there is a significant increase in annoyance when aircraft noise is increased. So typically, and this is consistent with what we observe in other studies, people do not notice reductions in aircraft noise as much as they notice increases. This is an unfortunate result for policy. The finding is consistent with, certainly with qualitative research that we've been carrying out in the UK. Number 3, comparison over time. Herr Schreckenberg has already discussed this chart here, that we have a significant increase in reported annoyance when we use LEQ as the scale. Frankfurt from 2005 to 2011, 12, 13. It doesn't appear to be anything to do with the northwest runway. It's just some general increase in reported annoyance. What is the reason for that? Okay. Findings 4. This is where Herr Schreckenberg did not dare to show in this funny sort of browny yellow colour the EU curve, the standardised EU curve, but I'm not scared of showing it, so I have done. And what this shows is that the EU curve, which is based on really old data, does not represent the current relationships where people appear, when you use LEQ as the scale, people appear to be much more annoyed now than they were when the data was collected, which supports the EU curve. There's also considerable differences between different studies, and as general trend, the EU curve underestimates more recent annoyance. It's just a piece of information. Okay. Possible explanations of that. Why has that happened? Have respondents really become more annoyed on average over time? Another possible explanation is that residents' annoyance hasn't actually changed, but the metrics are not quite represented what's really been happening, either in terms of what does the annoyance, reported annoyance scale really measure, or more possibly, what does the LEQ really measure? And is that measuring something which is truly relevant to annoyance? And we have to comment here that the curves are averages. They do not represent individual respondents, because individual respondents are all different. They're all exposed differently and they all have different opinions. The problem of metrics, this is data that I've reported before in other conferences of previous studies, UK studies. I'm comparing actual data now between 1982 and 2005, blue dots and red dots. The horizontal scales over here, the x-axis is the average sound level, that's like the peaks, Lmax, and this scale is the log number of events. So we're looking at the average noise level events and the number of events. You're going to tell me off and cut me off shortly, yes? Yes, I will. Okay. What we see there in terms of the average sound level, in 1982 the event sound level had a stronger effect than in 2005, but in 2005 the number of events had a stronger effect than the average sound level. We can plot out using different metrics, and you see over onto the left-hand chart using LEQ, the two lines for 2005 and 1982 are different. Okay, this way round, and showing an apparent increase in annoyance. But when we use a different metric along the bottom, which is, I don't have time to go into the details of that, but it takes greater account of the number of events than LEQ does, we can get the data lines to coincide, which suggests that perhaps a different metric might work better. Okay? Findings. Percentage highly annoyed at Frankfurt, Cologne, Berlin and Stuttgart. Respondents were relatively more annoyed at higher sound levels at Frankfurt and Stuttgart than at Cologne and Berlin. Why is that? Actually, we don't know, but it'd be interesting to explore that, because there must be something about non-acoustic factors are different here. We look at the sleep disturbance, the reported sleep disturbance, which is not the same as our colleagues yesterday were talking about actual sleep disturbance, and we find that respondents were at the same nighttime sound level, say at 55. Frankfurt showed higher reported sleep disturbance before the Northwest Runway, the night ban was introduced, than at the other than at Cologne-Bonn in particular, but they're similar at the lower sound levels, of course. Perhaps nighttime LEQ is not the best metric for this purpose either, because of that variation in response, or perhaps people at Cologne-Bonn have become more adapted to aircraft noise at night. I don't know if that's another possible explanation looking at the data. We do see a significant effect of the nighttime rest phase at Frankfurt when we go to 2012, 2013. So at least that appears to have had some beneficial effect. It may not have affected their actual sleep quality, but it certainly affected people's perceptions and reported perceptions of their sleep quality in terms of the way they report it in a... I've only got 3 slides left. Okay. Thank you. When we look at highly annoyed versus against aircraft noise, against Straße noise and Schienenalarm, we have a huge difference here. I don't know what the explanation for that is. Okay, it would be interesting to know. And secondly, it actually illustrates that while LEQ is a good metric, it is a good metric for physical sound because it's actually quantifiable. It's the average energy received on the ground for physical sound, which is skull. It's a very poor metric for predicting subjective noise, or I'm told that's larmempfinden, or perhaps someone will correct me on the pronunciation of that. These are different. Last two slides. Self-reported health-related quality of life was negatively associated with higher reported annoyance. I think that's a significant result, even if some of the other results of some of the other modules are less significant. We do have strong indications here that the non-acoustic factors are important, and annoyance can be important in other quality of life factors. And these findings suggest to me that greater attention to all the factors that you can discuss with the public in terms of more effective public engagement, such as trust in institutions and perceived procedural fairness here, these could all help to reduce perceived annoyance and hence actual reported annoyance, and improve self-reported health-related quality of life. Actually increase the sum of overall happiness. So the last slide. What next? NORAH has confirmed that aircraft noise continues to be a significant issue for many residents around major airports. It's shown that the study's also shown that on average, people report higher reported annoyance disturbance at the same LEQ, continuous sound level, at some airports than at others, and for aircraft noise compared to other transportation noise sources. There are many non-acoustic factors are important in addition to physical sound levels. People are complicated. And I haven't finished yet. I've got 3 more slides. 3 more points to mention. This is my last slide. Okay. Aircraft noise is just one of the environmental effects associated with airports. There's also air pollution and road traffic congestion. Airports also provide many social and economic benefits to travellers, to workers and to surrounding regions. And the future of civil aviation actually depends on finding an appropriate balance between all these many variables. And I think an increasing emphasis on public engagement might help to solve some of these questions. Now I've finished, and I've been 26 minutes.
That's okay. Thank you.
Thank you.
Just take a seat and take your headphones, that's important. Are there any questions? Gibt es Fragen? You're very welcome to pose the question in whatever language you like, as long as it's English or German. Wir haben Saalmikrofone, die herumlaufen.
We have microphones here. Please show me your hands. Are there any questions? So let us start here if our guests don't have a question. Oh, there is a question over there. Could you please introduce yourself? Wolfgang Eberle from the Environment Ministry, Rhineland-Palatinate. Even before NORAH, we knew that the EU exposure response curves are outdated. Could you please speak into the microphone? So let me repeat. The exposure response curves from the European Union are outdated. This is what we knew before NORAH was completed. We know that these kind of curves need to be reworked, had to be amended by different kind of functions and elements. And there is no representative from the Federal Environmental Ministry. This is why I would like to ask Dr. Schreckenberg, is the European Union being informed about the NORAH study and the findings of NORAH? Well, I hope that the members of the European Union in charge of noise abatement government will take the NORAH study into account, and I know that the World Health Organization is updating the noise guidelines at present. They see that there are some changes, also changes in the exposure response rate. And as far as noise annoyance is concerned, we can see that these changes are mapped, are reflected in the reviews. We can see that the noise annoyance is much higher than in the past few years, and this will be reflected in the WHO documents as well. And as far as I know, the European Union is highly interested in the WHO document, and therefore I assume that in spring 2016 the new noise guidelines will be published by the World Health Organization, and they will then also be copied by the European Union and implemented by the European Union. I think it is important to go back to what was said at the beginning of this conference. You cannot do without NORAH. There's no way to continue without NORAH. NORAH will be considered also by the European Union.
Da hinten ganz am Rand war eine Meldung und hier vorne.
We have a question over there and also in the front.
Ja, vielen
rows.
Dank. Ich habe mich gestern schon mal gemeldet.
Thank you very much for your presentation. Could you please introduce yourself? I just wanted to introduce myself. If you give me 2 more seconds, Arno Klane. I'm a member of the Social Democratic Party in the German Parliament, and I'm a member of the Traffic Committee. I introduced myself yesterday. I thought that you'll remember, but you don't. Okay. I have a typical political question. I learned from you, and I hope that I understood it correctly, that there are certain social factors like trust, confidence and fairness, which are also important factors which can contribute to more acceptance of noise annoyance. Which means, if I take a further step, that good communication is of utmost importance if you want to reduce the negative impact of noise. Can that be measured also by doctors? So good communication has a positive impact on noise annoyance, and this positive impact can also be measured by doctors. Or is it really, as Dr. Flindell said, people are complicated and we cannot measure that, this positive impact? I mean, on the one hand, we're doing research on social factors. We see that fairness, trust, mutual trust and confidence improve the situation for the people, but the noise remains the same. How can that be explained, that the acceptance goes up? Dr. Flindell, would you like to answer?
Yes, and I think it's a very good question. I think it's very perceptive of you to get that message, first of all. Secondly, when I say that issues such as procedural fairness and trust in making responsible, fair decisions are important for acceptability, they do not necessarily reduce annoyance. That's important. So it's a question of what you want to measure. What we want to actually measure, I think, is the public consensus as to whether or not the airport or any other environmental nuisance is actually worthwhile, whether the social and economic benefits outweigh the environmental disadvantages. And I think that annoyance is one part of that, but it shouldn't just be the focus. It's actually the question of how do the public perceive the balance, which is important. And I think we're only beginning to start doing research in these areas.
Herr Vogt?
Vielleicht noch eine Ergänzung dazu. Es gibt das Gebiet der Psychoneuroimmunologie.
We have the psychoneuroimmunology, and in this research it was proved that the correlation between annoyance and the health situation is really obvious. And as Dr. Flindell said, I mean, we have to do much more to identify these negative factors. We have to increase the quality of life of the people who are affected by noise. And we could see that NORAH is an excellent tool, for example, with the sleep study. We learned in the sleep study that people having a positive attitude towards noise sleep better. They are less annoyed. Of course, we have to be much more active with regard to noise abatement, active and passive noise abatement, but also these psychosocial factors have to be taken into account. Mr. Rösli, you wanted to make a statement, and somebody over there as well. You will get a microphone, Mr. Rösli. I would like to thank the three speakers for their excellent presentations, and the three of you also addressed the participation rate, the response rate, which is very important to get quantitative results. I was quite astonished to hear that in Frankfurt the response rate in the study was much lower than the response rate we had in railway and road studies. I mean, as far as I know, aircraft noise is a topic which is being discussed here all the time in the Frankfurt region. So how comes that the response rate is so low? I mean, I thought that people who are affected by aircraft noise would be more willing to participate in a study, and the contrary is the case. The response rate is so low. And then I would like to know how comes that the response rate is so low, even if the annoyance is so much higher than compared to the annoyance of railway or road noise. Well, I believe one possible explanation could be that people do not feel that much impacted, not that much annoyed. We believe that the annoyance is much bigger, but it seems to be that this is not the case. But other people also refuse to participate due to the fact that they do not believe that something will change. They are annoyed. They feel negatively impacted, but there is also a sort of resignation. They have resigned. They believe that their participation in that study will not make a change, and that might be another reason. And we recognize that, and this is why we said, okay, there might be some response distortions, but these response distortions are not one-sided. There are different reasons for refusing. As I said, some persons are not interested at all because they do not feel annoyed, but there are also other people who, well, have lost all their hopes, have resigned, and say that there is not much of a difference between Frankfurt Airport and Cologne Airport or Berlin Airport. And you're right, there are many discussions here in Frankfurt, and we have the study 2011 and 2012. The study was really discussed in detail, and the organizers of the study, the researchers, tried to motivate many people to take part. There were information in the internet on NORAH, and there were also doctors who complained about the study. They said, we all know that noise has a negative impact on health, so why are you trying to put the focus of the affected people even more on that problem? All these kind of things were discussed, but fortunately, these discussions did not have a negative effect. But as I said, some people some respondents said, my doctor recommended me not to take part in the study because this might be very demotivating. I also have a question. How comes that aviation noise is much more disturbing than railway noise or road noise, even if the peak levels in railway noise are much higher? Well, there are some theories. Maybe your personal perception is decisive. People assume that the noise caused by aircrafts are much more dangerous, have a higher negative impact, have a higher risk than, for example, railway noise, because everybody believes that train transportation, the railway system, is much more environmentally friendly. People are also afraid of planes, that planes might crash, well, there are some technical problems in flying, so the people have a different attitude towards flying. And Mr. Flindell also mentioned other acoustic factors which are not covered that well in the continuous sound level analysis. So the people feel threatened by aviation noise. Everybody who's living here and sees these huge planes flying over their house, and you see them landing, it is a kind of threat. The people are afraid of them, of these huge planes, and this is why they feel annoyed. It might drop on my house. I can see the train is here, the motorway is here, nothing will change. I know where they are, the location won't change. But what about planes? Mr. Flindell.
Wanted to say something.
Yes, Herr Schreckenberg mentioned my name about acoustic metrics. Now, it is true that there is more variability with aircraft noise flyovers than with railway noise or with road traffic. Road traffic varies a bit during the course of the day, but it's pretty much predictable what it will be like from one day to the next at different times of the day. A railway noise tends to be very predictable, actually, but for aircraft noise, it's highly variable because it depends on the way that the runways are being operated, easterly or westerly. It depends if Lufthansa are being particularly friendly to their passengers or not, which my flight was cancelled this afternoon. Thank you very much. So I have to take a different flight to a different airport to get home. But certainly, even, and this is relevant to the acoustics module as well, even the same aeroplane doing exactly the same thing on different days over the same point on the ground can have variability of as much as 10 or 15 decibels. That's due to variations in atmospheric propagation and various other unknown factors. So because of that variability, the metrics that we use in these trying to quantify exposure-response relationships have to concentrate on averages. So the prediction methods are averages. The LEQ is very much a long-term average. We don't know to what extent people's reported annoyance, and again, which is not necessarily the same thing as their perceived ideas of acceptability, we actually don't know if their annoyance is perhaps more affected by the occasional noisy event, which could be much noisier than the average for aircraft noise, and that would be more disturbing than the average. That could be a factor. It's very difficult to study that in the field because when you ask people for questions, you're not quite sure in the field, particularly in telephone interviews, how far back they are thinking when they're responding to the question. So there are still lots of uncertainties about these exposure-response relationships, and I'm personally not convinced that the responses between aircraft noise and road traffic and railway noise are that different, really, once you take into account the non-acoustical factors and the differences in the differences in the way that the standard metrics take account of the differences in sound.
Thank you, Herr Vogt.
Ja, nur ein letzter Punkt, den ich ergänzen möchte. Das Auto Oder die Bahn benutze ich halt selbst täglich.
I'm taking the train every day.
Täglich andere und ich selbst
Others
nur einmal im
are
Jahr oder
using
das spielt
planes,
sicherlich auch eine Rolle und
not
es
me,
braucht dann
maybe
eben
only
eine
once or twice a year.
gesamtgesellschaftliche Debatte, wie viel
And
wir bereit sind für Mobilität,
we have to discuss
Umwelt, Lebensqualität
how much do we want to
Vielen Dank.
sacrifice for having a better quality in life.
Ich glaube, der Herr ganz hinten war es.
I interrupted you. You wanted to ask a question or make a statement.
Vogelsang.
My name is Vogelsang from the Environmental Ministry of Rhineland-Palatinate.
Von 2005 nach 2012 oder 13.
Well, we could see a shift between the years 2011 and 2012. We can see that the decibel went down in flight noise, in aviation noise, but other metrical factors changed. The LEQ is not a good parameter, not the only parameter which gives us enough information. I have 100 planes with 100 decibel and then 90 planes with 110 decibel. And if you sum that up, the decibels, you will have the same noise annoyance. So we have to take a much thorougher look. And we can also say that the curves for road noise have not changed at all, which means that the noise characteristics have not changed as well. Maybe it is different for the railways. Thank you very much for your contribution, for your statement. It is giving us a very good part of the explanation, and Dr. Flindell showed us the curves for the UK, explained the different parameters. It does not explain, however, the situation in Frankfurt, because as far as I know, the number of flights have not changed that much, and the sound levels haven't changed that much either. Well, as far as I know, the number of flights haven't changed that much from the year 2012. They cannot explain the shift we have witnessed. I mean, talking about Frankfurt, we have to do research for many decades and not only focus on the years 2011 or 12.
Okay.
May I continue?
Ein möglicher Grund, den ich unterschlagen habe,
One
ist,
possible explanation I forgot to mention is the following. We always assumed that the opening, which took place on the 20th or 21st of October, when the new runway was opened, would be the day which would change everything. But it didn't. We started with our research in summer 2011, and since March 2012 we could see some changes of the flight routes. We could see changing from the 3 runways to the 4 runways, and this did not happen at midnight on the 21st of October. It was a process which was prepared for many months and took also many months to be fully implemented. So we had a longer transitional period.
Bunkowski vom Flughafenverband ADV.
Of the ADV Aircraft Association. Would like to come back to the determined difference in the study between the noise of air, road and railway. And if I understood you properly, this is due to the fact that aircraft noise is predominant in this region. Are there regions where it's the other way around, where there is more road or railway traffic? And if so, how do we arrive at these results? Because we need to determine them if we really want to properly compare. What we have done was a mapping that I showed to you with the 3 curves for the different sources of noise. And in these curves, we had the railway annoyance curve from the Rhine Valley study. I think we did it in 2010, around 2010. There we had a study about about the Rhine Valley along the railway link, and there was severe level of annoyance. The curve is higher in the NORAH study for aircraft, but it's for road annoyance, but it's still under the aircraft annoyance. Probably there are differences at the different locations. Well, with respect to road noise and rail noise, I would never say they are valid for all over Germany, but probably for regions close to an airport. I mean, this is typical for regions close to airports, that you're not only influenced by the noise level, but also by the very existence of the airport that is within reach. And this also has an effect on the assessment of the other sources of noise. Now, if I wanted to show an exposure response curve that is valid for all over Germany, also for road and railway noise, I would not study close to airports. I'd rather would start where the railway links are. What we found is true for people who live close to airports. Thank you very much, Mr. Schreckenberg. Are there any further questions?
Da kommt ein Mikrofon. Der Weg ist nur
The
weit.
microphone is brought to you.
Vielen Dank. Faulbaum, Universität Duisburg-Essen und
The
Sozialwissenschaftliches
University
Umfragezentrum in
Essen,
Duisburg.
and I work in
Wir
the
haben
survey
die Umfrage
center Duisburg. We carried out
Und
the survey,
Was mich bewegt,
and
ist eine
I'm
Klarstellung,
really
dass
moved
in die Kalkulation
by
der
the following. In the calculation of the response rate of 7%, what we also included those that were not registered in the telephone book, in the directory. So that must not be confused with refusal to participate. I mean, the respondents are not to be blamed for that, only indirectly, because, you know, they didn't allow that they were registered in the directory. And then another remark on the response rate. The pure response rate is not only a yardstick for lack of representation. If you contact 100 Chinese, 100,000 Chinese, and 1,000 are prepared to participate in the survey, and these 1,000 are a random sample of the 100,000, then this random sample still is representative, although it's only a very small percentage. Now, what is important? Distortion needs to be considered. Of course, we have to state that there are distortions in this survey, in this study, but the point is whether these distortions correlated with relevant variables studied. If they are not correlated, then distortions are not important in the interpretation of the results. Thank you.
Ja, ich wollte nur sagen, dass ich das alles richtig finde, was Sie erwähnt haben. Diese Diskussion, wie man diese Responsrate berechnet, das war eine lange Diskussion.
That was a lengthy discussion between WBQ and the consortium, and then later we agreed on the two forms calculated, that is 7% response rate, and then measured with the available telephone numbers, it was 17%. So we intensively discussed that, and then the different disciplines, epidemiology, social scientists, etc., really dealt with that. It was not just decided without basis. No, we had an intensive discussion among different disciplines, and I think the problem has been understood. Now we have to see what we do with the exposure response curves. I mean, not much happens with them. They are stable, and we have to see how for future studies we can motivate people to participate. And for that, we need to create trust into science and also in the way we organize the studies. Thank you. Any other questions? Yes, there is one.
Nachdem das niemand nachgefragt
Could you briefly introduce?
Nachdem das niemand nachgefragt hat, vielleicht bin ich der Einzige, der das nicht verstanden
I'm the only one who didn't get it. Probably, as no one asked about it. You had allocations of noise levels to all addresses, right? Yeah.
Das heißt,
which means the non-responder analysis could show whether there was a bias in a certain direction. And you needn't have to ask more people necessarily. Yeah, absolutely right. We thought whether we should do a non-responder questioning. Well, sounds paradox. How can you ask non-responders? I mean, it's the attempt, having someone on the telephone who says, I don't want to participate, but just get one or two questions answered on the phone. That is, how much do you feel to be annoyed, and then you can find whether there was a bias or not. I mean, it was not really successful. It was not necessary either, because the participation in this short non-responder survey, only some of the non-responders participated. But we did that. That's what you proposed. We looked whether the response rates were in between the noise level classes and whether they distributed differently. The hypothesis would be response rates would be lower in the areas where there are lower noise levels, but we didn't find that.
It's your turn.
Yeah, and also I'd like to add that from the UK experience, and I agree with Professor, I can't see your name, Professor Faulbaum, that actually the correct figure for the response rate is from the identified telephone numbers, which is the 17%. And from the United Kingdom experience for telephone interviews, that's actually a high response rate. We are lucky if we get 5%, because people in England are regularly phoned up by insurance salesmen about people, did you know that your bank owes you money for mis-selling you insurance? Thank you, bye. And so people often don't listen. It's very difficult to get people to answer telephone. So if part of the reason for the refusal is simply they don't really understand what the questionnaire is about, and they just put the phone down and say no without really listening, then there's no bias at all. There's no difference at all. If part of the reason for refusal is that people consider, oh, well, you know, I'm a bit interested in the airport, but not enough to be bothered to waste time on a telephone interview, you assume, therefore, that the responders possibly are actually more annoyed than the average. Now, I believe there's also a small number of people which Herr Schreckenberg has already referred to, who said, I'm not going to respond to this survey because it won't make any difference. I'm actually annoyed, but I'm too annoyed to even answer the telephone. I think that's probably only a small minority. And I have to say that in my United Kingdom experience, we've done quite a lot of qualitative, in-depth interviews with individual respondents face-to-face. We go to their homes. It's a very expensive method of research. But that my feeling from that is I would support the fact that it's unlikely to be biased downwards. If anything, the annoyance results have overestimated the average annoyance in the population.
Vielen Dank, Herr Vogt.
Ich wollte zum Kollegen
Let me mention to colleague Peter Lercher, this non-responder analysis was a big issue as well between WBQ and the consortium, and we basically don't know what people feel when they don't want to participate or drop down the phone. And if they say, I don't have time, we don't really know how much annoyed they are, if they have not participated in the short questionnaire. What we have to do probably for future studies, that all of us together, all stakeholders, try to strengthen confidence in studies like that, confidence in science, and spreading the knowledge that surveys like that are important for the development of our society. And then hopefully we can encourage people to at least briefly say how much they are annoyed, so that we can also do the non-responder analysis with the help of the noise levels. Okay, any other question, Mr. Faulbaum? Probably I can inform you about the fact that, as a matter of fact, there have been initiatives, Initiative Market and Social Research of the Council of Social and Marketing Research. And in this framework, the population shall be encouraged to develop more acceptance. They are ads, they are spots, TV spots, radio spots, etc. And from initiatives like that, we hope that people are more prepared to participate in surveys. As internationally and nationally, we have found that in Western countries, the response rates have continuously declined. And this is also due to the factors that Mr. Flindell mentioned. They have concerns about data protection sometimes. Then they have made bad experience, just as you said, you know, with PR calls. They try to sell any products to them, so they have a negative bias, and this reduces their preparedness to participate. The average preparedness to participate in telephone interviews is not 30%, but 20%. And if you don't do anything, if you don't offer any incentives, there were some methods to increase the preparedness to participate. So you should think of something. Have we got funds for further incentives so that they participate and can motivate people to participate? So there are quite a few factors that might be relevant. And then, of course, you have to consider that we mainly contacted them in the summer months. Although it was not the real holiday season here, summertime in general is a time where people go on holidays. Not only families with children travel, but probably also singles and other people travel a lot. And these are factors that determine whether we can reach them or not. And well, the response rate is not only the refusal that we include, but also those that we cannot reach. And we didn't reach people for many different reasons. Thank you very much for that hint. We have time for one short question in the back.
Da kommt ein Mikrofon.
Microphone is brought to you.
Ja. Nachdem wir jetzt die letzten 10
As
Minuten
in the past 10 minutes we have thought about the question why people don't participate properly in surveys, let me come back to another point that is also very important, and that's the question of communication and approaching each other, as Mr. Flindell mentioned right at the beginning of his talk. But this requires that either side, and with mediation procedures, that's something that we are looking at. So in mediation procedures, oftentimes it's forgotten that either party has to make concessions. It's not only to communicate the position in such a way that the other one accepts it. Let me give you an example. Since 1982, emissions of motorbikes have been radically changed. Without asking a single motorbike rider. I mean, it was found as annoyance and health problem, and then limit values were rigidly reduced, and even some roads were blocked. There have been regulatory interferences based on law. And that brings me to the question of the source of noise. So if the source of noise is not regulated, and in that case it's the aircraft or flying in general, if you don't regulate, then there won't be any communication between those annoyed and those who run airports or fly aircraft companies. And this leads to the question whether a society is prepared to say at certain points, now it's enough, as we have it for garbage, or other things that are being discussed lately. Is it an open question? Let me mention one more sentence. I've got one question, just as the other speakers. I don't have a question. No, these were no questions. These were declarations about the response rate and no questions.
Meine Frau nennt das immer das Anne-Will-Syndrom.
Wife calls it the Anne-Will-Syndrome. It's the moderator in TV.
Sagen Sie bitte, was Sie uns sagen möchten, und dann würden wir zum Ende kommen.
Can you tell us what you wanted to say?
Später bei den nächsten 2 Runden oder die da noch sind, vielleicht
probably in the next 2 rounds we can make it differently.
Das heißt, solange diese,
as long.
Und in dieser, nochmal ein weiterer Erklärungspunkt,
another point of explanation.
Workshop erkennen.
Although some of the
In der
workshops
Region
have
Rhein-Main gibt es eine Auseinandersetzung
den Flughafen
seit
has been a dispute about the airport for nearly 50 years. With one of the biggest social movements of the early 80s. That was a dispute about the runway west. And in this region, 200,000 signatures were collected for a referendum. So the quorum of a referendum was fulfilled, but a referendum did not take place because the court said that a referendum was not the responsible instance to decide on the airport, and there were psychological consequences on that. Some people became radical and blocked the motorway, etc., and the others resigned.
Aber diese Traditionslinie bestimmt,
this tradition line determines the different behavior with the same noise emission in Bonn or here in Frankfurt. And here the fronts are, and you hear it also, oftentimes there are 80 civic groups.
Vielen Dank, das
don't find it elsewhere, probably in Berlin-Brandenburg. I take that point up. Mr. Schreckenberg, what about the different perceptions? Why do people feel more annoyance here in Frankfurt than in Cologne, Stuttgart or Berlin? There might be different reasons for that. Of course, the assessment of the total situation, also the discussion about the extension of the airport, that definitely has an effect. I believe that as well. We have the discussion about runway number 4 and an extension since 1989. Since it has been announced that there is a wish for extension, for further extension, definitely this also has an effect. But this is not the only cause. It's also the change of flight traffic in general that has changed the annoyance, and that's an essential reason to communicate properly. Communication about the extension definitely also has an effect. But I believe that it's not only to say that people need to accept, they have to accept that there is annoyance. For me, communication is also important when taking noise abatement measures. When you look at the question, what can we do to abate noise? And here, it's not only what we do, but how we do it. That's important. And here we need to harmonize our approach with the public. I mean, it's expensive. You can offer passive abatement measures, or you can build sound insulation windows into the houses, but people are still not happy. Why? Because they feel locked up. Probably they cannot open their windows any longer, and you might have a ventilation system linked to it, and they are annoyed because they have to always stay with closed windows because of air traffic noise. And these are processes where we need to communicate more, not only to tolerate annoyance, but also to think about effective protection measures for the population. Thank you very much. Thank you, the three of you at the panel. Unfortunately, it's already late, and therefore, you can continue your discussions bilaterally.